solving 3 equations, 3 unknowns. So I have a couple of examples here for you, and they're not the prettiest of examples, and they actually don't give us, unique solutions, or at least one of them will not. The other one, I'm not sure. Okay, so we're going to take a look and try to see how we can solve these. Now, when you are solving these, most likely in kind of grade 12, either algebra or a vector course that you're taking, you're going to be looking at numerous ways of being able to solve 3 by 3 kind of equations where you have 3 unknowns. And please don't forget, what you are actually doing if you want to get some intuition into it. When you are dealing with 3 unknowns, so even in the second example, the one that has a T, a Q, and I guess an R. So I purposely changed the fact that, you're using X, Y, and Z, because that is something you get so used to in high school, and then you think everything is X, Y, and Z, which is not true. X, Y, and Z just stands for an unknown. It could be any quantity that you're trying to solve for. And if you go on into university, you're going to run into many unknowns, and the variables themselves, so the actual the X, the Y, and the Z, may be something completely different. Now, of course, in mathematics, it's very convenient and we stick to it. It kind of has a historical background, so it's fine. But we don't know what those X, Y, and Z stand for, at least most of the time. Now, when you do get into some applications, don't get flustered that you're going to see different variables, and don't think that they mean something different. You can still get intuition. The intuition is that you are dealing with 3 planes, and you're trying to see how those 3 planes are intersecting. That's your ultimate goal that you want to be able to see. Now, I've done an entire intuitive understanding how 3 planes can intersect. I'll put up a link up above there. But that's not the goal here. The goal here is to take the examples and then break them down to see if there is an intersection, if there is not an intersection, and also if there is not, what does that mean? Like, what is happening with those 3 planes? So I do want to go that deep just so that you learn to get, again, more and more intuition into like, okay, how am I supposed to be dealing and what am I finding out here? So let's take the first example, which is going to be this one. I'm going to take this example and we're going to break it down for ourselves. Let me maybe clear it up on a separate page. So here it is, okay? This one isn't actually as terrible. The coefficients that we have are all actually integers, so that makes it much nicer for us. And let's take a look and see how, we can progress through this. So one way is, what I kind of like to do is I just eliminate, and you can eliminate any variable that you like. You can pick one. Now, because I can see the X right there, notice I have an X in here, okay, and I have an X in here with a coefficient of 1. I can certainly get rid of those, okay, so by just simply combining these two, or at least subtracting those 2 equations from each other. So I can take equation 1, I can subtract equation 2, and then I'm going to get my result. So within here, so if I do that particular subtraction, what I'm going to get, the X's obviously cancel, and then I'm going to get 2 and then minus, so this is going to be just Y, and then I'm going to get negative and then minus, so this is going to be minus 3Z is equal to, and then 3 minus 1 is going to be 2. So now I have just 2 variables. If I now go back to 2 variables, it's basically thinking of a line, right, where just Y and Z are my 2 variables. Now, since I've canceled out my X, I am going to remove my X also, okay, from over here. Now, I can't just remove it by, either subtraction or an addition. So I am going to have to do something different. So for example, I will take, for instance, again, equation 1. But what I'm going to do to equation 1, I'm going to multiply that equation by 2. And that equation by 2, and then I'm going to subtract equation, I guess this is equation 3. So this is equation 1, 2, and 3 over here. Now, if I do that, so if I take twice the amount, I'm going to actually write it out just so that I have it in front of me. So this is going to be 2x 4y minus 2z is equal to 6. So that's the 2 times 1. Now I'm going to subtract the 3, so I'm going to just rewrite it here for myself. So this is what I'm going to have. And now I can subtract the 2. So subtracting these two, I'm going to get another equation, but now again the x is gone. So now here, once again, I have actually y. So that's what I see there. Negative 2 minus is going to be minus 3. Z is equal to, and then 6 minus, and I guess that's negative and negative. So that's going to be 10. So this is what I get. Now, what I have now is when I took equations 1 and 2, so what I noticed that the kind of intersection in between them, if I only worked between those two, this would have given me a line, okay, in terms of an intersecting set of points. And now if I took the equations 1 and 3, now just because of what I have done is notice this is what I get. And I also, it seems like I get a line. Now, right away, what I will notice is within here, now this doesn't always pop out at you right away. However, okay, notice that this, okay, and this, they're identical to each other, right? So the only difference is, you know, you have a 2 and then here you have a 10. So if you would deal now with these two, because now what you have really is you have 2 lines, right? So you have 2 lines, okay, within here, and now you want to be able to know, okay, do those actually intersect, and do they intersect at a point, okay, or do they maybe not intersect at all? Now, it seems that these two are going to be parallel because of the fact that I can take a look at the coefficients of y and z, so they're the same. But if they weren't the same, I can, of course, use the process of elimination again. So I can take those two, y minus 3z is equal to 2, so that's that first one that I got. And then the second one, 1 minus 3z is equal to 10, so that's the second one. So let's say you didn't notice, but now you say, oh, well, you know, I'm going to get rid of my y. Now, if you do this subtraction, what you'll notice here is you're going to get 0 on the left-hand side, and you're going to get negative 8 on the right-hand side. Now, what does that tell us? Well, this tells us that these two lines do not intersect. They're actually parallel to each other, right? So this is what's going to happen, okay? So that they do not intersect, okay, at all. Now, they're parallel. They're parallel within respect to here, but not necessarily maybe in 3 dimensions. We would have to kind of just double check what happens there, okay, with those lines. But the algebra, okay, tells us that we are now working, okay, with an actual system of 3 equations which do not have a solution. So this would tell us that there is no solution at all, right? So that's what we would get. So there's no solution in here that we're going to obtain for this. So it's not a point, it's not a line, and they're definitely not lines lying on top of each other. So those are the 3 things that can happen. So the system is inconsistent. There is no solution. Now, what if you wanted to know a little bit more? Or what if your teacher said, okay, if there's no solution, then what happens to these planes? Because they do seem to align, at least 2 planes at a time, seem to align, and they seem to intersect at an actual line, right? So now what you could do is, you know, so what could this possibly mean in terms of planes if you were thinking about them? Well, you could possibly have, so since they're intersecting at an actual line, then you have a plane, okay, which goes on now, however it is plotted, okay, so let's say it's one plane, so let's say this was plane 1. You know that there is another plane, okay, that is going to be intersecting, okay, so this one right there, okay, so let's say, so that's my intersection right here, so that's the line. So let's say, you know, this, okay, when we were doing this, you know, maybe this is the line, okay, of the actual intersection, okay, within there. So that's what we would have. But this also happens over here, right, with the other 2. Now, this was between 1 and 3. So what could possibly happen? Well, what could happen is that you have another, you know, plane, and maybe, you know, with the other plane, okay, over here, maybe it's intersecting like this, right? So maybe you have something like this, okay, and these two are maybe in some way parallel or something of that nature. But now you can also ask yourself, all right, so how about these two planes, right? So how about this one and this one? So if this is equation 2 and this is equation 3, right? Are these actually parallel to each other? You know, are these two planes parallel to each other, or do they intersect? Now, you can check that for yourself. You can check line 2 and line 3 just by looking at the normals. So notice from line 2, the normal itself, so this is the normal of 2, okay, is equal to, so this is just the coefficients 1, 1, and 2. The normal of the third one, this is going to be 2, 3, and 1. And you can see here, so these are actually, okay, so these particular normals, okay, that you have, they're definitely not parallel and they're not scalar multiples of each other at all. So if you take, let's say, the 3 and the 2, so let's say if you take these, right, you'll notice that you would have to multiply this by 2, so this becomes a 2. But if you do that, then this would become by a 2 and this would become a 4. And therefore, this would not be a scalar multiple. So they're not scalar multiples of each other. So it looks like this is not what happens, right? So this is not what happens, which means that what actually does happen is that these two must intersect. And if, so meaning the plane 2 and plane 3, these must intersect. So what you actually are referring to now is you have, you know what, one plane, okay, you have another plane, okay, which is going to intersect over here, like so. So, and this continues on, okay, over there. So that plane, okay, so it's intersecting right here. And, okay, so what else happens is that you have these two, okay, so these two planes, so this one, okay, and this one, they're also intersecting each other. So maybe somewhere over here, right? So maybe they're intersecting like this, and then they're intersecting this one. Okay, so this maybe continues on over there. So you have kind of created, okay, almost like this triangle of planes. And what I, okay, have done kind of it behind the scenes here, so let me take this out, okay, and just show it to you. So here it is. So here's kind of the planes that we have in here, okay, so those are the three planes, and notice this is exactly, so you have the yellow, the red, okay, and then the orange, okay, so those are the planes going through, and they do intersect at a line, each of them, but they never, all three simultaneously do not intersect. So that's what happens. Now, your teachers may not ask you about this, but it is good to have some intuition of what actually happens. If you're just interested, if you have a consistent, meaning there is a solution, or if there is no solution, then that's fine. You could have just done these particular steps, okay, that you saw here. So you can go all the way through here and say, okay, there's no solution in here, and you're done. But, you know, maybe if part B was, well, okay, so well then what really happens? At least you can have a sense of an understanding where you can work with the normals, see if they're parallel or not, or some scalar multiples of each other, okay, to be able to see how these planes actually do intersect. So that's example 1. I think this is a great example. It forces you to really think about, okay, what happens in here. Now, for your own test, what I would encourage you to do is to take the 3 normals from here. Now that we kind of know that this is what happens, okay, take those 3 normals right there, and then find the actual scalar product, okay, within here. So if you take these right there, okay, and you do this, then that scalar, that triple scalar product will tell you that actually those normals are lying in a coplanar form, because that scalar product is going to be equal to 0. And that's going to tell you that they were actually in a planar form, which means that it was one of these cases. Okay, now it turned out to be this case, okay, as you saw. Now for that triple scalar product, I'll put up a link up above there. so that you can go back to it if you wanted to be able to learn it. All right, so now, okay, we have this ugly set. And not only do we have an ugly set, okay, within here, we also are not dealing with X, Y, and Z. Now, please don't let this trip you up. That is irrelevant what variables they use, right? It does not matter. Now, of course, X, Y, Z is so common, so that we know that it's our three-dimensional coordinate system, and X, Y is our two-dimensional coordinate system. But it doesn't matter, right? So you can still line them up as you like. So if you have these three equations where you have these coefficients, and not only do we not have X, Y, and Z, we also have ugly coefficients. They're decimals. So how am I going to be dealing with, trying to solve something like this? So to get rid of decimals, you of course, if you recall the two-dimensional system of linear equations when there was only X and a Y, you can always just multiply by powers of 10 to get rid of them, right? So I'm going to put up a link up above there. Okay, this will date you back to grade 10. But let's try to solve this, and let's see, again, they're still planes. We just renamed T, Q, and R instead of X, Y, and Z, but we can still think of them as planes. So let's try this. Now I'm going to rearrange. So it's Q, R, T, so I guess Q is going to be first. So I'm going to switch everything over, all right? So this is what I'm going to do. So step one, let me realign this. So 2.1, this is going to be negative because I'm shifting it over on the other side. Q, R, so this is going to be a T. So there's no R. So I'm going to just put plus 0 R. Okay, minus 0.2t is equal to negative 2. So this one looks a little bit better. I'm going to get rid of, okay, so that's the other part is, I'm going to get rid of the decimals, and I want to get rid of this negative in front here. So I'm going to multiply this actually by negative 10. Now, why negative 10? Because I only have one decimal place. So this is going to change over. It's going to be 21q. Of course, this is still 0. This is going to be now positive 2t, and this is going to be positive 20. So that looks a little bit better, all right? So just kind of realign this one. Remember, you can multiply and move things around as long as you're multiplying both the left-hand side and the right-hand side. All right, so that's my, let's call this equation 1. So that's from there. Now, for number 2, so for this one, what I'm going to do is I'm going to just switch things around again. So QRT. So that's going to be 1.5. Let me again, so maybe multiply this now by 10. So that's going to be, so this is going to be my equation 2. So this is going to be 15Q. The R, so it's going to be minus 7R. And then this 3t, okay, I'm going to bring it over on the other side. It's going to be negative 3t, but it was multiplied by 10. So negative 30t, and is equal to 5. All right. Now for the third one, so for this one, again, I guess I'm going to multiply by 10. So this is going to be my third one. So my q, if I bring it over, that's 18. And you know what, I don't want to do too many steps at one time. So okay, hold on, forget it. Let's not do this. I'm just going to shift things over first because I see that it's going to be negative. So negative 1.8 q plus 2r plus 0.6 t and equals to 0.8. All right. Let me get rid of this, okay? And now I'm going to multiply actually by negative 10. So that's going to be 18q minus, this is going to be 20, r, and then minus 6t, and then minus 8. So those are going to be my equations. Let me get, chuck this out of the way now. All right, so just I can shift this over. Okay, I'm going to move this, and I know it's tiny, and shifting it out of the way over here. All right, so let it be there. So that's my 3 equations now. And notice, so although I don't have X, Y, and Z or Z, I do have QRT. I put them in alphabetical order. QR, I guess it's not purely alphabetical, but it's QRT. Okay, I guess there's an S somewhere in there. So now what do you do, right? So you're kind of stuck with this, and now you want to be able to solve this. And the numbers are not very pretty either, you know, so you're going to be kind of having to work with relatively ugly numbers in here. So this indeed is not going to be a fun kind of result, okay, in terms of going through this. So we can certainly simplify this as much as possible. So 21, I have a 2 and 20. So I don't really have a common factor I can kind of divide by. So the greatest common factor within here. The second line, 15, 7, third. Okay, that also doesn't work. But actually this one, I can divide this by 2. I can see that. So that's going to be 9. I don't know if this is going to help or not, but it's always nicer to have smaller numbers. 3t is equal to -4. So that's going to be smaller than it was. All right, so that's what I have there. So now, okay, so how do I proceed? I do already, you know, I can see here that this right here, so the r is equal to 0. So I can try, okay, to get rid of the r as well. So I'm going to actually get rid of the r over here. So I'm going to get rid of this. Now the reason for that is because of the fact that I see 20 and 10, right? So, oops, I'm sorry. That's silly me, because those ones are from the same equation. I just divided it by 2. So that would have been an error in there. So, okay, let's see. That's 7, 10. Well, that doesn't really nicely work out. This one might work out. Okay, so I have 30, so from equation 2, and then 3 from here. So what I can try to do is the following. So I can take this. So I have, so that equation 1, which is 21q. Okay, I'm going to get rid of that r. This is t is equal to 20, so that was one of them. Now the t, okay, so I can get rid of, okay, is the t's from another equation, okay, over there. But I'm still going to get stuck with the r. Okay, so notice, okay, so as I'm working through this, and this is exactly what you're going to have to do. So this is a good exercise for yourself. I am going to get rid of the r. Okay, you know what? I'm going to do it. Now, it's not going to give me anything pretty, but that's fine. So let's get rid of this, okay, and this. All right, so I have 7 and 10. Okay, so what I'm going to do is I'm going to multiply the equation 2 by 10. So that's my equation 2 by 10. And then I'm going to subtract 7 times this equation 3. Okay, and the equation 3, so that's this one. All right, so that's that. So if I do this, so let's see what we get. Okay, so if I multiply equation 2 by 10, so I get 150q minus 70r minus 300t is equal to 50, so it's very ugly. My equation 3 by 7, so 7 times 9, that's going to be 63q. This is going to be minus 70r, and then minus 21t is equal to minus 28. Now subtracting them, okay, right there, so I am indeed going to get rid of this. Now 150 minus 63, all right, so I should be able to do that in my head. Okay, 87. So 87q, the r is gone, and then I have negative 300t minus, so that's positive. So it's going to be minus 279t, is equal to, and this is going to be 78. All right, so now I have, okay, two equations. So this one and this one. That's from my equation 1. All right, so I have these two now equations. So as you can see, this becomes really ugly. And it can happen. Now, hopefully your teachers won't give you things that are this ugly, but it's worth giving it a try. Now, the one thing that I do notice, okay, so within here, just by looking at the coefficients right there, this is going to give me a solution. This is not going to be, lines that are going to be causing me problems. So now you might say, okay, so what should I do here? Right? What's the easiest thing to do? Do I still, let's say, do I get rid of Q or do I get rid of T, right? Do I use elimination? You're not stuck with elimination. So I'm actually going to use substitution. So what I'm going to do is I'm going to take my, this equation, so this one right here, I'm going to isolate it for T. Okay, so this is going to give me, so 2T equals 20 minus 21Q. Divided by 2 on both sides, so it's going to be 10 minus, this is 21 over 2q. Okay, so this is my t. So I isolated, and now I have to substitute back into here to get my result. Now, it's still going to be very ugly. Okay, so minus 279, and this is going to be 10 minus 21 over 2q, so I'm substituting 78. Okay, so this is what I have. So 87q minus 2790, so I'm just distributing this across. This is really, really ugly. Plus, and now unfortunately, okay, I have no idea what this will be. So 279 multiplied by, this is 21, all over 2. All right, yeah, so that's super ugly, but that's fine. Okay, so let's take a look here. So that's 5859 all over 2q, so that's just distributed this across through here, equals 278. Okay, now I mean, this is not a bad decimal to deal with, so I can certainly do that. So it's 2929.5, just Q. Okay, so that's this one, if you want it to stay in decimal form. So now I have, so this, okay, and this. So my answer plus 87 is going to be 3016.5 Q equals, and now I have 78, bring over that 2790 to the other side. So that's 78 plus 2790 equals, so that's 2868. So you're using quite a lot of your skills to be able to solve this, and then you have your answer. So 2868 divided by 3016.5. Now, when it is this ugly, don't be shocked. Okay, so there you go. That we do get, now we're going to have to get approximate answers. Okay, so within here. So one of the reasons, if you wanted to stay with fractions, you could, because then you're going to get exact answers. But if you take this, this is going to be 0, 7, 7, and so on. So this is something in fractional form. So I could have stayed in fractional form over here if I wanted to, right? And then carried this throughout. And then this would have given me an answer. Because now, once you have this, so now that you've solved for Q, you're going to take your Q and you're going to be substituting back into your equations. So for example, you can substitute into here, and you're going to get what the value of T is. And once you get the value of T, you can take your Q and your T, and then you can substitute back into one of the original equations. You can even go back all the way, okay, because now we want to solve for R, so you can, plug it into here or plug it into here to be able to solve for your R. Okay, so that's the process, both of elimination, now substitution. Now what this tells us is that there is one unique solution. So these three planes are intersecting at one point. All right. So now by the substitutions, okay, I'm going to put the answer right there, at least the approximate answer, and maybe I'll round everything off, okay, to let's say two decimal places or something like that, okay, and then I'll provide you the answer, and you can work this out on your own as well, just to see if you can finish this off, okay, so by substituting into the other ones. All right, so that is it for this video. So these are two great examples that you can test yourself on, okay, if you understand on how to solve for an unknown with 3 equations, 3 unknowns. Okay, thanks for watching. See you in a future video. Bye, everybody. Cheers.